Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of recursive sequences, specifically how we can evaluate both arithmetic and geometric sequences, and we'll do it in 5 minutes or less. So I've got two different sequences up here on the screen. We're going to look at both of them side by side so we can see the difference. Alright, so our first one is going to be our arithmetic sequences. Now we've been dealing with sequences for many years, finding patterns and finding rules. But this is how we can display it with an equation. So an arithmetic sequence is going to look like this, where a to the n, or a of n, is equal to a of n minus 1 plus d. This d right here is my difference. So this is how the sequence is changing arithmetically. So typically it's going to be an integer, right? So let's say that we're going to make my sequence go up by 5s. All right, so if I wanted to add 5 every time, I'm going to replace that d with just a plus 5. If I wanted to subtract 3, I would just do a minus 3. Now, what we need to know is the first number of our sequence is going to be a of 0, right? So our first number of our sequence, and let's say it starts at 8. We're going to go up in, as you can see, our n, our number of each sequence is going to go up whole numbers, right? And as long as that n is going to be greater than 1, right? So let's see what we would have. Well, we're going to start with that 8 right there. That's our first number, okay? Now, if our n is going to be greater than 1, and they have to be a whole number, right? Let's evaluate that a of 2. Let's see what that second number in the sequence is going to be. So I would say a of 2 equals a of 2 minus 1 plus 5. Okay, so a of 2 minus 1, that means a of 1 plus 5. What was my first number of my sequence? That's going to be 8 plus 5. That equals 13. All right, so my second number, a of 2, is going to equal 13 because that's a plus 5. I could do a of 3. That's going to equal a of n minus 1, so a of 3 minus 1 plus 5. That equals a of 2 plus 5, which a of 2 was 13, right? That's my second number of my sequence, plus 5, so that's going to equal 18. Now, we can go on and on and on, but hopefully you see the pattern here. We're just adding 5 each time, but this is how we can evaluate it with the nth term. Now, this other sequence over here is going to be a geometric sequence. And hopefully you'll see it's going to be a little bit different. So we're going to take this r. This is going to be our ratio. So rather than a difference, we're going to multiply it by a common ratio. Once again, we need to take n's as whole numbers greater than 1, and our a of 0 needs to be something specific. So let's say our sequence is going to be a of n equal, let's make our ratio, let's make it 5. Right, our difference was 5 in the other one. Let's make that 5. And then we're going to do times a n minus 1. And let's say our a to the 0, right, is going to equal, let's make it 8. Let's just see what happens when we look at it geometrically rather than arithmetically. Okay, so we're going to start a sequence here. First number is going to be 8, right? What's our second number going to be? Well, a of 2 is going to equal a of n minus 1. So, and we need that ratio. That ratio is going to be 5. So let's go ahead and put that first. And then times a of n minus 1. So that's going to be 2 minus 1. So that's going to be 5 times a to the 1. What was that first sequence? Was 8. So that's 5 times 8. So that equals 40. Okay? Then if we wanted to do that same thing, we would do 5 a of 3 minus 1 since we're in the third term. So it's 5 times a to the second, which is going to equal 5 times 40, which, wow, that's going to equal 200. And you see how we're just going to get bigger and bigger and bigger because we're multiplying by 5 each time here geometrically, and we're just going to keep getting larger and larger and larger. It's going to get up to 1,000. Whereas over here, we were adding by 5. So big difference between the two.